Hello, everyone. This is a CloudKicks Foundation data synchronization demo. We're going to be covering rsync. Who am I? My name is Alphonse Hoge, and I'm involved with the CloudKicks Foundation. We are an informal group of people that help promote CloudKicks open source community. The company that I work for full-time uses CloudKicks infrastructure to host some of our internal systems. There are many use cases where you want to transfer data into and out of or within CloudKicks, and we are recommending that you use rsync for this purpose. Rsync is a synchronization tool, and in this tutorial we'll see that while designed for synchronization, it can and should be used to copy. It is more versatile than copy utilities such as SCP, as well as being more powerful. It is faster, more secure, and better supported than many of the other copy utilities. rsync was developed a long time ago, 1996, and it uses TCP/IP port 22 for communication by default. It is possible to connect it to a daemon using a different protocol, but at this day and age, you're hardly never going to see rsync used other than over SSH. So if you have an SSH tool that already works to a target host, to which if you're working, you're going to have one, then you can use rsync to the same device without creating any additional firewall rules. I have been using rsync on a daily basis for over 20 years, and I'd like to share some of these experiences with you guys. So why rsync? It is very fast because it compresses data in transit. It's extraordinarily versatile with many, many options. Copy locally, to and from another remote host, over any remote shell, not only SSH, or like I mentioned before, to a remote rsync daemon, which we are not going to cover in this demo. rsync offers many options that control every aspect of its behavior and permits very flexible specification of the set of files to be copied. rsync is famous for its delta transfer algorithm, which reduces the amount of data sent over the network by sending only the differences between the source file and the existing target file at the destination. rsync is widely used for backups and mirroring, and as an improved copy command for everyday use. When used with cron jobs, it is ideal for the automation of backups. The main thing is, if rsync is interrupted during a data transfer, it can be trivially restarted and continue from where it was previously stopped. In case of SCP, if it's a large file, you're going to start copying the file again from the beginning. The use cases: local, remote, local. You will see that we're using a -A option on all of these cases, which is the most commonly used option, and it stands for archive mode. And in this case, it'll copy directories recursively and maintain file permissions. My personal suggestions: always use dry run on untested commands. This will help prevent data loss by verifying that you are copying the right data from the correct source to the correct destination. Options in rsync have a short version preceded by a single hyphen, or a long version preceded by 2 hyphens. Thus, A and -- archive both represent the same option. For future readability and when writing automation script, I suggest you to use the long option. In the command line on day-to-day use, short option is fine. If you're going to write a script that needs to be read by somebody else, I suggest you use the long option. Until you know exactly what the options do, avoid options that set other options. I mean, A is just one example, but there are other examples of other single-letter options that set multiple options. Put plenty of comments in your scripts, and always create a log file. This is a very simplistic diagram for what we have. My laptop here, we have the internet, obviously, we have the CloudKicks infrastructure, and then we have 2 Ubuntus defined there. So there's connectivity from the outside world to the project, to the 2 VMs, and then between the 2 VMs because they're sitting on the same segment. I created this project with 2 Ubuntu virtual machines connected to the same segment with the following public IP addresses. The details of how to create a similar project are included, but I'm not going to cover them here. Before we can do anything, we need to create some test data. I've decided to use a bash script file to quickly create some files. It creates 3 sets of files, 100 files in each, simple text, random, uncompressible, and 0 field files, highly compressible. Since rsync has many options, and it is very flexible, that's why it has many options. But you mustn't be discouraged because most of the options are not going to be used in a day-to-day situation. You're going to get familiar with a couple of commands. Anything fancier, you're going to have a script. So you don't necessarily need to know the finer points of all the thousands of options. One of the key options that we are going to use is the -A or -- archive option. So in this case, the -A and -- archive represents R, L, P, T, G, and O, and D, right, options. So we're going to recurse through the directories. We're going to copy symlinks as symlinks. We're going to preserve the permissions, times, groups, and ownership attributes of the file. And if we're talking about devices or special files, we're going to preserve those as well. There are many other options. Dry run, which I have mentioned before. It shows everything that it would do, but does not make any changes. Verbose increases the verbosity of the output to the terminal. Compress should be used at all times. It won't be done on a local file transfer, but it's a good habit to have it there. And human readable makes the output more legible. The dry run option, again, it's not a matter of if you're going to make mistakes with rsync, it's a matter of when you're going to make mistakes. So you get into the habit of using the dry run option, especially when you're making changes to commands that you've used before. And obviously read and verify the output to see that what you wanted to do is actually what it will do once you take the dry run option out. The delete options. Delete options are only really applicable in the realm of synchronization of 2 data sets. If you're copying files for backup purposes or moving them somewhere, you don't necessarily want to delete files that already exist on the target. If you're synchronizing data sets, you definitely want to delete files that no longer exist on the source, but still exist on the target. What do these various options do? Again, if it doesn't exist at the source, but already exists at the destination, you might want to delete it. All of them only delete files at the target, and then you can choose to do it before the transfer, after the transfer, or during the transfer. And we also have the option of deleting any files that we have excluded. And the delay is just an additional option that speeds up in the specific case where you have chosen to do a delete after. Exclude options, you can type what you want excluded. You can exclude patterns by entering patterns, or you can enter the list of patterns or list of files from a file. What do they do? There's undoubtedly going to be files that you want to exclude when you're making copies. Things like DSStore or thumbsdb and transient compilation artifacts from your compiling environment. These are typically not required and not desired to have present on the target system. The Git repo files, in the case where you want to create a working copy of your current environment, then you do not want to exclude Git repo files. For backup purposes, you may want to exclude that. Now, there are many ways to exclude files. These are the options that can be used. Again, if you're unsure of what the option does, don't exclude it. Worst case scenario, you're going to have some extra files on the target that you didn't want. Now, let's have a look at the commands from the terminal. We are now going to do the rsync demo itself. I have 3 terminals set up. Blue is my home terminal, and it's on my local laptop. Green is Ubuntu 1, which is a virtual machine at CloudKicks. Yellow is Ubuntu 2, another virtual machine at CloudKicks. I'm going to start this exercise back on my home terminal, where I have set up a test file, just some random text. I'm demonstrating how to transfer files from your local machine into a virtual machine that Cloud kicks, in this case Ubuntu One. Run the command, enter the password, rsync considered one file and transferred one file. If I go ahead and run the same command again, you see rsync still considered one file, but because nothing has changed, it has transferred nothing. If we go and have a look at Ubuntu One, let's exit this. We have 3 directories: receive, send, new dir, and my script file. The script file is to create some test files. If we have a quick look at the script, we see that it's going to create 300 files of different types. I now run the script. It has created a whole bunch of files that we are going to use for this demo. First thing I want to show on my local machine is a local transfer. I'm using rsync to do a local copy from send directory to the receive directory. The transfer of 300 files takes a little bit longer. We see 300 files considered and 300 files sent. Again, if we repeat the command, rsync sends nothing because nothing has changed on the source or on the target side. Rsync only transfers what has changed. If we change the receive side by removing some files, say files that start with file 5, and we run the same command again, you see that rsync still considered 300 files, but only transferred the 11 files that were not present on the target directory. If we go ahead and remove an additional set of files, and we use a slightly different commands, you can see the use of the progress option. So again, rsync transferred only the files that were missing. But if you have a look, rsync provided a progress report during the transfer. Let us remove another set of files. I'm now going to show the itemize changes option. This is very useful as it details what has occurred. So now rsync is not giving you the progress output. It's still providing the statistics. However, now we see the detailed changes that have occurred. Now, how do you know what all these changes mean? You have a look at the man page for rsync, which I know is not installed on this system. So I'm going to go back to my local machine and we're going to do a man rsync. Rsync is very flexible, so the manual is very verbose. Lots of items, lots of options for you to look at. The one that I want to point out is way at the end under itemized changes. It gives you an explanation of what each of the characters mean. It can be confusing, and as time progresses, you'll get used to it. So if you want to find out what something means, you look here and, for example, see that the greater than sign means that the file is being transferred to the local system, which is correct since we are transferring from local system to the local system. If we were sending it to another host, you would see a less than sign. All right, let's go back to the terminal one and let's do some additional commands. Let's remove another set of files here so that we have some activity and I can show you the use of the log command. If you are doing large file transfers or many file transfers, and you're not going to be sitting in front of the terminal and waiting. You want to be able to move away and come back later and know what has occurred. We're still using the statistics output, but this time we're going to send the output to the log file. Rsync has created a log file and transferred 11 files. If we have a look at the log file itself, it contains the statistics at the end of the transfer, but it now also contains the itemized outputs previously seen using the itemize option during transfers. So if you're going to walk away, there's no need to have anything come out to the terminal. You could choose the same exact command and drop the statistics. Just remember that you're not going to get the statistics in the log file. If you want both statistics, you need to set it in the command line. It's a matter of personal choice, really. Obviously, keep in mind that if you're going to run away from the terminal, you should probably be using screen or tmux to run these commands. Make sure that you don't lose your standard in and standard out. Now we're going to do something slightly different. We're going to send files between the two virtual machines. If we go to terminal 2, we have a similar layout, a send directory, a receive directory, etc. Receive is empty, so let's go back to terminal 1. We are going to send files with the same options, but this time we're going to transfer the send directory to a remote host using SSH with the user code of administrator. We run the command, present the password. It does take some time. rsync has considered 300 files, and it has transferred all the files. Again, as always, if you send the command again, nothing is going to be sent. We change over to Ubuntu 2 and remove the 5 meg files and start with file 5. Back on Ubuntu 1 and use the same command. Transferred 11 files. I want to point out this figure here, the speed up of 11,585. This is a comparison of a transfer without compression and a transfer with compression. The 5 meg files are filled with zeros, so they're highly compressible. This is why you get this gigantic 11,000-fold figure. Let's remove a different set of files. This time we're going to remove the 2 meg files and do the same command again. Now we see something slightly different. The speed up figure is much smaller since the 2 meg files contain random data. Since they're not compressible at all, you get some benefit for the compression, but not as much. Now I want to show a different transfer. We are going to pull the files from Ubuntu 2 into the received directory. I'm also going to add the use of an SSH key. I'm sick and tired of typing passwords, so we're going to use an SSH key that I had already created on Ubuntu 1. I also placed the public part of that key on Ubuntu 2. At this day and age, we really should not be using passwords at all. Sometimes they are sent in the clear, and it is a real risk. No files were transferred because, as you recall, we previously sent everything. If I go to Ubuntu 2 and remove files, so I've removed some files on Ubuntu 2, then back on Ubuntu 1, I'm going to remove a different set of files. Say any file with file 1 in its name. So what we have created here is a situation where the files have been removed from both the source and from the target directory. If we go ahead and do the pull command again, rsync has copied 11 files over. The end result is that these directories are out of sync because there are files that exist on both ends that do not exist at the opposite end. This is because we did not use any of the various delete options. The delete option is a topic for another section. Just keep in mind that they are required for synchronizing file sets. I want to end the session by going back to Terminal 1. If you recall, this is my local system where we started by sending this file to Ubuntu 1. The file's already there, so nothing has been transferred. Let's suppose I really wanted to send this file over. I'm going to use the same command, or what seems to be the same command, and do this transfer. Enter my password. Now, rsync is telling us that it would have transferred 101 files, which is not what I intended to do. I made a mistake. The mistake is trivial. I got the send and receive order wrong. It's obvious once you look at it. However, it happens to everyone. I'm trying to point out that if you're doing something slightly different, or if you are unsure, please use the dry run option. It shows you what would have occurred without affecting any files. Thank you very much.